Okay, this is lesson 5.2 where we're talking about proportions. And it says proportion. A proportion is an equation stating that two ratios are equivalent. Two quantities that form a proportion are proportional. But if you look down where it says numbers, 2/3 equals 4/6. This is really just looking at two equivalent fractions. So remember, proportions are like fractions, but really what we're looking at here is making these two things that look like fractions equal to each other. So for example 1, determining whether ratios form a proportion. And it says, tell whether 6/4 and 8/12 form a proportion. Well, you can compare the ratios in simplest form. So we simplify 6/4 to 3/2, and we simplify 8/12 to 2/3. We know that 3/2 and 2/3 are not equal, so this does not form a proportion. So the first way they give us is to simplify both ratios and see if in their simplified form they are equal. In example 2 here, determining whether two quantities are proportional, what they're doing is they simplified all of these as well. They made them all x over y. So they went to the table, they put each x term over its corresponding y term, and then what they did is they simplified them all, and they showed that they are all equal to 1/6. Because they're all equal to 1/6, they're all equal to each other. The next key idea is cross products. I love cross products. In the proportion, A/B equals C/D. So that's just two fractions. They're saying they're equal to each other because it called it a proportion. The products A and D and B and C are called cross products. So notice A times D goes one cross, and then B times C goes the other cross. And the cross products property says that if those two are a proportion, so if the two fractions are equal, then the cross products must be equal. So let's look down where it says numbers. 2/3 equals 4/6. We know that. But if you look at the cross products, 2 times 6, that equals 12. And the other cross product, 3 times 4, that equals 12. So if the cross products are equal, if you can multiply the cross products and they are equal, then the two ratios do form a proportion. In example 3, identifying proportional relationships, it says you swim your first 4 laps in 2.4 minutes. You complete 16 laps in 12 minutes. Is the number of laps proportional to your time? Well, let's look. First, we take 2.4 over 4, and the second one is 12/16. They take the first 2.4 minutes over 4 laps and they turn it into its unit rate. Remember, we turn it into its unit rate by making the denominator a 1. And we always do this by dividing top and bottom by the denominator. So we take 2.4 over 4, we divide top and bottom by 4, and we get 0.6 minutes per lap. We do the same thing over 12/16. We divide top and bottom by 16, so we can get 1 on the bottom, and it ends up being 0.75 over 1, or 0.75 minutes per lap. 0.6 minutes per lap and 0.75 minutes per lap are not the same thing. So those are not equivalent. And they showed that by making them both into their unit rates. The second method, I find a little easier. They just took 2.4 minutes over 4 laps and 12 minutes over 16 laps and found their cross products. 4 times 12 is 48. 2.4 times 16 is 38.4. They're not the same, so it's not a proportion.